What distinguishes the landscape from studio subjects is the presence of two powerful light sources, one a direct light and the other an indirect reflected light. And the two sources of light have opposite color temperatures, one warm and the other cool. The sun is the obvious direct light source, and its temperature is always warm. What's not so obvious is the secondary light source, the sky, which is always cool. The sky acts as an enormous light reflector that surrounds every landscape object on all sides and illuminates all sides equally with its dominant cooling temperature. When sunlight strikes the particles of atmosphere that surround the Earth, they reflect back the blue portion of the light spectrum, giving us the appearance of blue sky. In the landscape, you have to always consider this other light source, the sky, because you can't get rid of it, minimize it, or control it. There are three types of shadows in the landscape: cast shadows, form shadows, and open shadows. Cast shadows are those which are created by the interruption of sunlight by striking an object. The shadow of that object is laid down onto the surface beside it or behind it. It is cool because it's always illuminated from directly overhead and 360 degrees around by the reflected blue light from the sky. This is the source of the rule for warm light, cool shadows. This rule has been greatly misunderstood and misused because it doesn't address what happens with form shadows and open shadows. They almost never follow this rule, but are as prevalent in the landscape as the cast shadows. Sometimes even cast shadows don't follow the rule, as we'll see in a later demonstration. The rule should say, for clarity, warm light, cool cast shadows. Form shadows occur on the shadow side of a sunlit object. These occur in the landscape as well as in the still life. The form shadow occurs right next to the end of the light on the object and is most often warm rather than cool. Open shadows are the shadow sides of objects that receive their light from surfaces and objects other than the sky. They are universally warm in temperature. For instance, if you observe a structure such as an archway made of cold-colored stone, you'll see that the temperature of the cast shadow on the vertical side of the arch is cool, as you would expect from the rule, warm light, cool shadows. But on the underside of the arch, at the highest point, the temperature of this deep shadow is not cool at all. It's warm. Oh, you can't tell by the photograph? Well, that's the usual problem. Many painters use photographs as their sole reference for painting, and they really don't contain enough temperature information that you could see if you were standing there in front of the scene. To overcome this deficiency, photographers have had to do what they call bracketing by taking at least 3 photos of the same place, one at a normal light setting, one at overexposure mode, and one in underexposure mode. What this does is allow them to see into the deep shadows in the overexposed photograph, as you see here. All the light and middle value areas are washed out and unusable. But see what becomes obvious when you look into the dark areas. Up under the arch, you see that the temperature of the shadow shifts to a very warm color. Look at the cast shadow on the inside of the arch. It's very cool as it runs down the side of the structure. Why does this shadow change color and temperature? Because the light that illuminates the high underside of the archway is reflected from the Earth's surface, a surface that's warm, not cool. This section is defined as open shadow. It runs right into the cast shadow on the side of the arch, which, now in its vertical position, faces a portion of the sky, that great cool light source that illuminates all cast shadows in the landscape. This painting, executed on location, accurately captures the changing temperature of the color of the shadows on this arch as they change from cast shadow to open shadow. If you're not prepared to look for these nuances in nature, you'll miss what is sometimes the most interesting part of a scene to paint. Consider this open interior courtyard that has plenty of sunlight and deep cast shadows. The sunlight is warm by definition, and the cast shadows are definitely cool. But look at the open shadows up under the arched portico. They are intensely warm, more so than the blanched out walls that are struck by sunlight. This oil sketch, executed on location here a few years earlier and not from a photograph, correctly interprets the relative temperature seen in both the cast shadows and in the great interior colonnades of mostly open shadows. All openings into buildings, whether they are open doorways or open windows, should be rendered as warm tones, not cool ones, to accurately represent the temperature that exists in these situations. Often a painter can't really tell whether the color is warm or cool because it's too dark, or if using a photograph there's no color cue to work from. Almost always the novice painter will make those dark values too cool in temperature, and consequently the color combinations won't feel right, even though he's used the rule warm light, cool shadows. He'll know something is vaguely wrong but can't figure out what it is, especially if the value is right. What is wrong is that he's confused a cast shadow with an open shadow. The open shadow is always illuminated by the warm earth forms surrounding it, whether it be a room inhabited by humans or animals, or shaded with natural living vegetation like trees. Living things reflect warm colors. In landscapes, always paint open shadows warm, and you'll be safe in making that decision when you can't yet see it for yourself. To show you how another shadow type can change from warm to cool, observe this situation where the group of trees casts a shadow onto the low stone wall behind them. On the outer edge, the cast shadow is very cool and much lighter in value than the shadows to the left up under the trees. This is because there's a lot of sky in the opening over the water, reflecting bright blue light into the shadow. But look at what happens as the shadow moves deeper behind the masked trees. There's no longer any blue sky illuminating the wall. What then is providing the reflected light that allows us to see color and value in that wall? It's the ambient light that's reflecting all around on the ground and from the undersides of the leaves of the trees back up and down onto the wall. These colors on the ground are uniformly more warm in temperature than the cool blue of the sky. Therefore, the wall in deepest open shadow is warm in temperature, not cool. What we are witnessing here is the presence of several other light sources in the landscape, not just the sun and the sky. Every surface that receives any kind of light will reflect that light in its own local color and temperature. So when sunlight hits the green grass, the light reflected off the grass will be green in color and relatively warm in temperature compared to the sky. When the sky is obscured from providing light in a landscape, the light reflected from other surfaces takes over to illuminate covered and deeply shadowed areas. Another example of this can be seen in the cast shadows on the pond scum on this quiet, still bayou. The sunlight is from the upper left, creating cast shadows on the pond surface from the trees on the bank. Where the cast shadows are illuminated by the sky, out in the open, these cast shadows are blue. But as the cast shadow approaches the bank, the color and temperature of the cast shadow becomes warmer and more yellow-green. Why is this? It's because the trees are close enough together to close the sky opening that would illuminate these shadows. So where is the light coming from that lets us see any color at all in these shadows? It's coming from light bouncing off the tree foliage, which is obviously yellow-green. Sunny days in the landscape create a riot of color in the shadow planes that almost has to be experienced firsthand to be able to believe it. Capturing these minimal effects with a photograph are a beginning, but they are no substitute for looking with your own eyes. Compare how this scene looks through the camera with the way I sense the colors at the scene. The painting shows so much more color interest than the photograph, and I assure you I didn't invent all the colors. They were there for inspiration. Oh, perhaps I exaggerated them a bit, but they were there in one degree or another. This painting, also executed on location during the same time period, shows a completely different color scheme and range of temperatures, something that occurred naturally and was unplanned. The individual location suggests its own treatment and color choices, along with color and temperature choices for the light and shadow areas. The third type of shadow in the landscape is the form shadow. This can be illustrated best by looking at something that has no color of its own. This is the Trevi Fountain in Rome, and is made entirely of white marble. The color effects seen on it are all directly related to the color of the light illuminating its surfaces, both directly and indirectly. Observe that the direct sunlight completely washes out any color other than the white of the surfaces in the sunlit areas. The cast shadows are uniformly cool and blue in color, caused by the illumination of the shadow sides from the sky. But where are the warm colors seen in the statuary coming from? On closer look, you'll see that the color defining the shadow side of the form is uniformly warm in temperature. Why? Because these areas are illuminated strongly by the sunlight reflected off neighboring surfaces. It's obvious when a shadow changes from a cast shadow to an open shadow, and just as obvious which are form shadows rather than cast shadows. If you look deeply into the apse behind the central statue, and we overexpose the photograph to see into the depth, you'll see the transition from a cool cast shadow on the right to a warm open shadow on the left. The dark warm color can come only from the light reflected off the surfaces surrounding it, not directly from the sun, nor from the sky. Hence, you can make a generalization that will make your painting tasks easier by understanding and remembering that all open shadows are warm. Following are a series of photos of a painting I did of the central statue in the Trevi Fountain grouping. It shows how I accomplished the task of painting the cool cast shadows and differentiated them from the warm open shadows and form shadows seen on the sculpture. As a matter of procedure, I made a precise pencil drawing of the sculpture to work out the drawing details off canvas. Then I transferred my drawing to the painting surface cleanly with graphite. The only time I do this rather than drawing and painting directly on the canvas is when the subject is so intricate as this is. The small size of the canvas, a 9 by 12, made it doubly important to work out the drawing details before I started painting. As with any painting, my procedure is to lay in the darkest shapes first. In this case, the white statue is silhouetted by the dark background of the apse, presenting the statue in strong relief. The apse was carefully planned by the architect to provide this dark contrast to the statue's white surface, no matter from which direction it is viewed. I immediately lay in the warm to cool transition in the apse to capture the actual light effects seen in these areas, even though they're not yet as dark as they ultimately will be. I've used only 2 colors plus white in the execution of this little painting, primarily to show the difference in temperatures of the 2 great light sources. The warm color is burnt sienna and the cool color is ultramarine blue. I did tone my canvas before starting with a light beige tone of raw umber, but I didn't use raw umber anywhere else in the subsequent painting. Everything in this stage is painted with thin, transparent glazes of colors. The colors seen in between the warm sienna and the cool ultramarine are mixtures of the two colors together. I solved the problem of avoiding muddy or nondescript colors by first laying down a single temperature color on the statue with the warm sienna, then allow it to dry before applying the cool ultramarine. Notice that this color is laid into all the form shadows of the sculpture. When dry, I add the cool colors into the cast shadow areas of the statue, leaving the unpainted canvas to stand for all the areas struck by direct sunlight. Successive layers of glazes into the dark background of the apse bring the statue more into relief and focus as the contrast between the statue and its background increases. Once all the dark areas are painted to their full range, then I begin to lay on my opaque paints. Again, as a matter of procedure, I find my darkest values read best when they're painted transparently rather than opaquely. And, by contrast, light values read best when they're painted opaquely. And I try not to mix the two in the wet painting sessions. I use fast-drying mediums to speed the drying time of the transparent colors, so I don't have to wait unnecessarily long before beginning the application of opaque paints. When I'm painting from life, either in studio or out of doors, I use my solvent as my medium because it evaporates quickly, leaving the pigment to dry fairly quickly because it's so thinly applied. If glazes are required, however, I then have to wait until each layer is completely dry before applying another. When I paint in this fashion, as I have in this illustration, I use a quick-drying painting medium to speed the drying time between paint glazes. I begin the opaque application of light values with a warm white on the lightest areas of the statue. The only other opaque paint applications are in the areas where there's a slightly lighter value needed in the shadow area, like the edges of the blowing shawl or lights on the Corinthian capitals of the columns. This particular painting has few opaque colors. More opaque colors are unnecessary to capture the warm and cool play of colors in this instance. Correctly placing temperatures on any of your landscape forms will give your paintings more volume and presence. Sometimes a local color makes it more difficult to see temperature changes as dramatically as seen in this demonstration, which is why I chose a colorless white object to show the effect. But these effects occur on objects that have lively local colors of their own. It's just not so obvious. But if you know where and what to look for, it won't be so confusing, and you should be able to capture these effects seen on color objects just as easily.